SMDP, by the way, there's an entire literature about semi-Markov decision processes well beyond the sort of scope of this lesson. But from our point of view, what's really neat about this, and this comes up again and again when you use SMDPs, is that once we define an SMDP and the appropriate Bellman operator for it, we can basically just pretend that it's an MDP because at bottom it is an MDP, and these expectations allow us to ground out in that MDP. And so we can just pretend we're always dealing with an MDP and we only have to deal with the fact that it's an SMDP. It just works. I take an option as just an action. It just takes time and is an atomic, but whatever. I might as well treat them as if they're atomic. I just let it run and it comes back. And when it comes back, it will have accumulated for me all the reward that I would accumulate if I were living in the underlying MDP, and it will discount the future in exactly the right way after I've taken K steps.
Woo!
Yes, exactly. So this is a lot of sort of equation writing and deltas and delta raised to powers and expectations that allows us to say, you know what, we're still dealing with MDPs with options. Everything we knew before works.
Okay, that's a relief, I guess, that we didn't have to throw all that out and start afresh.
Yeah, and again, I mean, it's actually important. This is, for me, this seemed like a subtle point for a long time, but it's actually not that subtle. It's just an SMDP is just an MDP, and where we have to keep track of the fact that our actions are not atomic and accumulate reward and accumulate all the transitions. But really, that's all captured very nicely by this expectation. It just means we have to hide things like the discount factors inside of our functions, whereas before with the MDP, we could stick them outside of the transition functions.
Okay. Well, I'm not quite getting the name, I think. Semi-Markov decision process sounds like it's, kind of Markov, but also kind of not Markov.
Yeah, that's right. It's semi-Markov.
But this seems Markov, right? I mean, underneath, it's just a whole bunch of standard MDP type transitions.
Yeah, that's exactly right. But what's allowing it, but at the level of the options, right, it's not Markov because you have to know how much time has passed.
Oh, I see. So the state that we end up in could actually depend on how much time we've spent, how much time has elapsed.
In fact, it will, in general, right? Because if I do it in one step, I'm going to end up in some state. I can't reach the states that are more than one step away. If I take 10 steps, then I can reach more states. So the state I end up in does depend upon K. It depends upon how long the option was executed. And in general, since beta is a probability over states, it could happen at any time.
I see. So it's got elements of Markov and elements of not Markov.
Right.
So elements of Markov include things like, well, we can think about the probability distribution over where we're going to end up. It really is Markov.
Mm-hmm.
But we have to be much more careful when we actually sum up rewards because the time that has elapsed is variable. And so we have to actually take into consideration how many steps have passed to do that.
Right, and how do we and in fact, that's a very important point, and I'll sort of point out two things here. One is, when we have a process that is not Markovian, often we can turn basically any non-Markovian process into a Markovian process by just keeping track of enough history, right?
Mm.
And history is often, time is enough. Sometimes you actually want to know what states you visited, but often time is enough. And so we can turn a non-Markovian thing into a Markovian thing. And in some ways, that's what we're doing here, right? We are keeping track of the places that we saw in between. But at the level of the SMDP, at the level of the options, I can ignore the MDP and pretend that the SMDP is an MDP and that these are really atomic actions. But in reality, they aren't, which is why R and F actually depend upon K. It actually matters how many steps you took, and that affects the expectation. And in fact, if you look at R, I'm actually accumulating all the rewards. So I'm taking something that's non-Markovian because it depends upon the actual rewards that I see, which depends upon the actual states that I visited. And I'm gathering them with me as I go along so that when I pop out a level, it goes back to looking Markovian again.
Cool.
Right. So an SMDP, it's an MDP, and I don't have to think about it anymore.
I feel like I'm getting the kind of math of this, but it's still a bit of an abstraction to me. Can we get into some kind of an example to practice these ideas?
So yes, first I want to point out that I appreciate the pun, using the word abstraction here.
Thanks.
Really good. I like that. But I think the answer is both yes and no. I'm going to go through an example that I think might help you think a little bit about this. But I also think that actually working out all these expectations would take us a long time, and it's a really good and useful exercise, which is why it should probably be an exercise. We'll let the students do it.
I mean, I don't know. It seems like a cool exercise in dynamic programming and algorithm design.
But Michael, you think everything is a cool exercise in dynamic programming?
Well, that may be, but that's because everything is a cool exercise in dynamic programming.
Yes, that's an excellent point, and why we're going to move on to the next slide.